Hello, I'm Nils Gottfries, professor of economics at Uppsala University and the author of the book Macroeconomics. And this is a quick introduction to chapter 9 in the book, which is on economic activity and inflation in the short run. So in chapter 8, we discuss the ISLM model, which describes the demand side of the economy in the short run. And the short run meant that we took the price level as given. And we looked at how the interest rate was determined in the money market and how production was determined in the product market. But of course, prices are not constant. Most of the time there is inflation, so there is a gradual increase in the price level. And also, we know from the long run analysis that production should eventually go back to the natural level. That if production is above the natural level, then wages will increase and eventually that should push production back to the natural level. But to understand this in more detail, we need a theory of how wages and prices adjust. And that is what we're going to present in this chapter. So this chapter is about the supply side in the short run. And that means it's about wage and price adjustment. And it's a key chapter because it actually ties the short run analysis together with the long run analysis. Because it tells you that, okay, if production is above the natural level, how will that affect wages and how will that eventually bring the economy back to the long-run equilibrium? So when you talk about economic activity and inflation, you talk about the Phillips curve, which is a relation between activity and inflation. And in fact, we will go through 3 versions of a Phillips curve. We will start in the labor market with wage formation and look at the relation between unemployment and wage inflation, and we'll end up in the product market with a relation between the output gap and price inflation, where the output gap is the deviation of production from its natural level. And in between, we'll also have a Phillips curve that relates unemployment and price inflation. So these are different measures of economic activity, different measures of inflation. And once we analyze the Phillips curve, we will realize that expectations play a key role, as everywhere else in economics, and that the position of the Phillips curve will depend on expectations about inflation. And we discuss in the chapter how these expectations might be formed and the implications of that for inflation, unemployment. And the underlying question in this chapter is really, is there a choice between low inflation and low unemployment? A very important question for economic policy. So we start in the labor market, and we start from the wage equation that we had in chapter 6 that says that if unemployment is above the equilibrium level, then companies want to reduce their wages relative to other firms. So if you think of a time where wages typically rise, you could say that if unemployment is above the equilibrium level, then each company wants to raise its wage less than the other firms raise them. So in that chapter, we show that you could write the wage equation in terms of changes over time. So the desired wage change of a firm is equal to the average wage increase in the market minus a coefficient B times the deviation of unemployment from its natural level. So this says that if unemployment is on its natural level, the firm wants to raise the wage in line with the average wage growth in the labor market. But if unemployment is above the natural level, then each individual firm wants to raise its wage less. So this is an equation about how firms want to set their wages if they can set them freely. And it's illustrated here in the graph. Now, we know that wages are typically set in nominal terms, in terms of money. and they don't change every day or every week. So in order to get a theory of wage adjustment, we need to have some idea about when firms change. So we will construct now a very simple model of nominal wage adjustment. And we do that in the following way. We simply assume that a share 1 minus lambda of the firms set the wage at the end of the previous year for the coming year. And we denote that wage that those firms set the rigid wage, WR. So the period is a year, and these firms set the wage the year before. They set the wage for 2020 in 2019. And then we have a share lambda of firms that just have flexible wages. They can change wages whenever they want. And that means that the average wage increase in the economy is going to be lambda times the wage increase for the flexible firms plus 1 minus lambda times the wage increase for the firms that set wages the year before. So now we need to figure out how those two groups of firms actually set their wages. Well, for the flexible firms, it's easy. They just set their desired wage increase, which is determined by the wage equation from Chapter 6. So they set the wage in line with the general wage increase, but they also take account of unemployment. So if unemployment is high, they raise their wages less. So what about the firms that set the wages the year before? Well, we will assume that they set their wage based on expectations about the average wage increase. So they just look ahead and say, we think that next year wages will increase 4%. Well, then we set 4% wage increase. And in the book, there is an argument for why this is reasonable, so it's not picked out of the air. Okay, so what is then the average wage increase in the economy? Well, you just know that the general wage increase is lambda times the wage increase of the flexible firms, and we have the equation for that. And then 1 minus lambda times the expected wage increase, because we said that those who set rigid wages, they raise wages in line with the expected wage increase. And that's it. You have an equation here that determines the average wage increase, and you can solve for that. And then you get that the general wage increase is the expected wage increase minus beta hat times the deviation of unemployment from the natural level. And beta hat is lambda times b over 1 minus lambda. So that is straightforward to check that derivation. And now we have our first Phillips curve that relates the wage increase to the expected wage increase and the level of unemployment. And we can look at this slope of the Phillips curve here, beta hat. The slope is determined by two parameters, b and lambda. And if they are large, the Phillips curve will have a steep slope. And beta actually measures how much firms want to change wages when unemployment increases. So if beta is high, it says that unemployment has a big negative effect on the desired wage increase. And lambda is the fraction of companies that can adjust wages freely. So the more firms want to respond to unemployment and the more firms that have flexible wages, the steeper is the Phillips curve. Yes, that is the Phillips curve in terms of unemployment and wage increases. So it says that if unemployment is high, there will be low wage increases. If unemployment is low, there will be high wage increases. And if unemployment is on the natural rate, then the wage increase will be in line with the expected wage increase. We will discuss later how these expectations might be formed. So an important insight here is that, okay, there is a negative relation between unemployment and wage inflation, but the position of that curve depends on the expectations. And of course, expectations can change quite quickly. So this Phillips curve might actually shift up and down depending on what people expect. And this is the Phillips curve in the labor market relating wage inflation to unemployment. So we want to ask what this implies for price inflation. So we want to go from wages to prices. Then, of course, we want to use our price equation from chapter 2. And to simplify this analysis, we disregard capital. So we assume that you only use labor for production. So in the production function, we set alpha equals 0. That means that our production function collapses to y equals en. And we omit capital just to simplify this. And you just have to trust me that we don't miss anything really important. And we know from the price equation that we derived in chapter 2 that the price is set with a markup on the marginal cost. And with this production function, the marginal cost of producing a unit of the goods is just the wage dividing by E, which is the productivity of the worker. And now we can use again our famous rule of thumb that says that if the markup is constant, then the percentage change in prices, that is inflation, is going to be the percentage change in wages minus the percentage change in productivity. And now we assume the same applies to expected inflation. It's reasonable to think that if people expect some wage increase and some productivity increase, then for consistency, they expect the inflation to be that wage increase minus the expected productivity increase. So it is rational that people have expectations which are consistent with how inflation is actually determined. And now, from using this, we can easily derive a Phillips curve for inflation. And the derivation here is slightly different from that in the book, but it amounts to the same thing. So basically what I do here is I take those two equations here for inflation and for the expected inflation. These are two equalities. And I now take the left-hand side of the lower equation, subtract from the left-hand side of the higher equation. So I subtract the expected inflation from inflation, and I subtract this thing here from this right-hand side here, which is the wage increase minus the productivity increase. And since these two are equalities, then if we do that, we should still have an equality. And then we get this, the deviation of inflation from expected inflation is equal to the deviation of wage increase from the expected wage increase minus the deviation of productivity from the expected productivity growth. And now that we have this, we can just use our equation for wage growth, and the equation for wage growth implies that the difference between wage growth and expected wage growth is minus beta times the deviation of unemployment from the natural rate. So we substitute that in place of this deviation of wages from expected wages. And there we have the Phillips curve. We can just move the expected inflation to the right-hand side if we want. And now we have an equation for inflation, how it's determined in the short run. And you see that inflation is determined by three things: the expected inflation and the unemployment relative to the natural level of unemployment, and finally the unexpected change in productivity. So if productivity rises, that will reduce inflation. So this is the Phillips curve that relates inflation to unemployment. High unemployment reduces inflation, but inflation also depends on the expected rate of inflation and also on unexpected productivity shocks. And we simplify notation by writing it like this. Z represents unexpected changes in productivity, but also more generally shocks to inflation. So prices may depend on various other things than wages. For example, oil prices may go up and that will affect price of level in the economy. So Z represents various kind of shocks to inflation, and we call them cost push shocks. So now we have this Phillips curve relating inflation to unemployment. But when we look at economic policy, it is useful to write the Phillips curve in terms of the output gap and price inflation. Because when we look at policy, we look at production and how monetary and fiscal policy affect production. And then it's interesting to relate to see how production and inflation are related. So in order to get to production, we use the production function. And the intuition is, of course, that if unemployment is low, then employment is high, so production is high. So we now use just the definitions here, that unemployment is the labor force minus the number of people employed divided by the labor force. We have the production function y equals En, where n is employment, and then we have the same is true for the natural level of production. And in the Phillips curve, we had this cyclical unemployment, that is the deviation of unemployment from the natural level. And if you use these relations, you can find that the deviation of unemployment from the natural level is equal to the expression on the right-hand side, which is one factor here, times the output gap, which is the deviation of production from its natural level divided by the natural level. And we call this thing here, we call it the output gap. It tells you by how many percent production deviates from the natural level. And the thing multiplying this is the natural level of production divided by E times L. And in this short-run analysis, we take these as given. So we can view this as a constant, this factor here. So then we see that there is a one-to-one relation between the deviation of unemployment from the natural level and the output gap. And it's a negative, there's a minus sign. So this algebra says a very simple thing, that when production is above the natural level, then unemployment is below the natural level. So if production is above the natural level, then this is positive. We have a positive thing here, and we have a minus sign. That means that unemployment must be lower than the natural level, so that this is negative. And that's what this says, that if production goes up, unemployment goes down. Not very surprising. And if we use that to replace cyclical unemployment in the Phillips curve, then we get our final Phillips curve. We won't have any more now. So that says that inflation is equal to expected inflation plus a coefficient beta times the output gap plus the cost push shock Z. And where the beta now is a little bit more complicated, but we don't need to go into that here. And I've illustrated this Phillips curve here. So here we have production on the horizontal axis and inflation on the vertical axis. And if production is on the natural level here, and there is no cost push shock, then inflation is going to be equal to the expected rate of inflation, because then Z is 0 and the output gap is 0, and then inflation is equal to the expected rate of inflation. But if production is higher, so it's here, then there is a positive output gap. Production is higher than the natural level, and then inflation is going to be higher than the expected inflation. And that's because then this term is positive. So this is the Phillips curve in terms of output and inflation. And that version of the Phillips curve is useful for analyzing economic policy, as we will see in the next chapter when we talk about monetary policy. Inflation depends on three things. It depends on the expected inflation rate, it depends on the output gap, and it depends on what you might call cost push shocks. Changes in productivity, taxes, energy prices, and so that affect inflation. And it's important to understand that the position of the Phillips curve depends on expected inflation. And that means that there is a relation between output gap and inflation, but the position of that Phillips curve may be quite unstable. It may move quite a lot depending on people's expectations about inflation. And this, of course, leads to the question of how inflation expectations are formed. And in this chapter, there are three cases that are discussed. And the first case is the possibility that people don't think there will be any inflation. Another possible assumption about expectations is that people think that inflation will be the same as the previous year. They maybe read in the newspapers that inflation was this, and then they expect it to continue on that level. A third possibility is that you have a central bank which has an inflation target, which I denote by pi with this little pizza on its beside it. And then we're not talking about the price of pizza now. We're talking about the general price level. But then a third possibility is that, well, people think that, well, we have this central bank and they have this 2% inflation target, so probably inflation is going to be 2%. That might also be a plausible idea about how people form expectations. So in the chapter, all these three cases are discussed. I will just very briefly discuss the middle case where people form expectations based on history. So if that is the case, then the Phillips curve takes this form that inflation depends on what inflation was in the previous year, because that is how expectations are formed, and then it depends on the output gap, and then it depends on the cost push shock. And that means that when we draw the Phillips curve in this diagram with inflation here and output here, then if production is on its natural level, then inflation will be the same as last year. And of course, this means that the Phillips curve will move up and down depending on what inflation was in the previous year. And what are the consequences of that? Well, let's very quickly discuss that. Okay, so we assume now there are no cost push shocks. So let us consider the following situation. Inflation is pi 0, and people expect inflation therefore to be pi 0, and production is on its natural level. So then the Phillips curve is here. And as long as production is on its natural level, then inflation remains at pi 0. And this is a long-run equilibrium because inflation is what people expected it to be. But then we assume that in period 1, the central bank pursues a more expansionary policy. They increase money growth, so the interest rate falls, and activity increases, so production increases from yn to y1. But since people expected inflation to be pi 0, the Phillips curve is here. This is the Phillips curve for period 1. And then production went up to y1, then the inflation rate will be pi 1. So in period 1, when you increase the money supply, then inflation is going to be pi 1, which is higher than people expected. So the expansion of the money supply led to an increase in production and an increase in inflation. But then the question is, what happens in the next period? Period 2. Well, in period 2, people observed that in period 1, inflation was pi 1, and that determines their expectations. So they expect inflation to be pi 1. And that means that the Phillips curve now shifts up in period 2 to this curve, which intersects this line for the natural level of production at inflation rate pi 1. But suppose now that the central bank continues to pursue an expansionary policy, increasing the money supply so as to keep production on this high level, well, then, since the Phillips curve is now this one for period 2, then if production is y1, then inflation is going to be pi 2. So you see that inflation is rising further. So as long as the central bank keeps production above the natural level, inflation will increase. So it's not just that prices will increase, but the rate of change of prices will increase. And you could continue this, and inflation could eventually become 10% and 20% and 50% and 100% if you continue to print a lot of money so as to keep production at a high level. So this illustrates the fact that the Phillips curve is not stable in this case. It's going to move with expectations. And this is not really a sustainable situation that you keep production on the level y1 above the natural level, because you will have ever increasing inflation. So eventually the central bank will have to reverse its policy. It cannot keep production on this level. Eventually the central bank will have to stop the growth of inflation, and the only way you can do that is to bring production down to the natural level. So this illustrates that it's impossible for the central bank to keep production above the natural level. Eventually, production must go back to the natural level. But if they do that and inflation is high and money growth is high, well, then you're in a situation with high inflation, high money growth, but production is again on its natural level. So we have again come back to the idea of neutrality of money, that in the long run, higher money growth will bring inflation, but it will not affect the real side of the economy. It will not affect employment and production, which is the feature that we had when we looked at the real side in the long run in chapters 2 to 7. You will understand this in more detail when you study this chapter. And there's also in this chapter some discussion of the data, what it looks like. If you look at the United States here, for example, this shows deviation from trend in GDP and the change in inflation. So this graph corresponds really to this Phillips curve. If there's no cost push shock, suppose you take this equation and move the previous inflation rate, subtract that on both sides, then you have that the change in inflation is positively related to the output gap. And this figure for the United States shows that there is some truth in that. The black line is the deviation of GDP from trend, and the blue line is the change in inflation. So there seemed to be a relation between those two, especially maybe in the 70s when inflation was moving a lot. So it was sometimes high, sometimes low. In that period, you see a fairly clear relation between the change in inflation and the deviation of production from trend. Okay, so in this chapter, you will understand how economic activity and inflation are related in the short run. So good luck with your studies of this chapter.